Welcome everybody from the Nano Safety Cluster Working Group A on Education, Training and Communication, but as well from the NanoCommons and the NanoSolvit projects. This is Martin Himli speaking. I'm the chair of the Working Group A of the Nano Safety Cluster. And I will give you a short introduction, as you can see on the very first slide, on what the NanoCommons project wants to do. And then I would also like to introduce Hari, so Haralambos Sarimbeis from the National Technical University of Athens, to give an introduction on the QSAR predictive modeling by Jackpot. And then Philip Doganis is going to guide you through Jackpot in an easy access way by use of Google Colab notebooks, QSAR modeling session, by help also of three colleagues of his. So NanoCommons, I don't need to tell in front of this audience probably that what kind of gaps we are standing in front of regarding the data landscape in nano safety assessment. And this is the big endeavor that NanoCommons tries to fill by trying to bridge fragmented and maybe inaccessible data for nano safety assessment. Read-across approaches, for instance, depending on data that also are complemented with a quite complete metadata set in order to be able to work on this. So we are in NanoCommons creating an e-infrastructure platform for reproducible science. We try to integrate as many models, tools available, and therefore we are also going to invite potential owners of tools and models to join our integrative community building platform, this NanoCommons platform. You see here on this slide that we have been in contact and we are collaborating with many different stakeholders in the field in order to fill the gaps that are currently hindering eventually a couple of process in risk management, risk assessment. What are we and how are we doing this? We are basically aligning our services, our consultancy, our trainings also along different categories that are somehow oriented on the data lifecycle. So spanning actually the area from the experimental workflows on to data processing and analysis, to data visualization, prediction models, up to the data storage and providing also a fair data accessibility. I would like to announce at this stage that we have transnational access services available still while the project is running. Of course, we want to sustain everything which is developed at the moment within this project. But during this lifetime of the project, we have this possibility of transnational access services where funding is provided for expert time in order to also support you with your actual research questions. Please consult this email address here, get in touch with us, and we will distribute you to the best fitting experts to get in touch with you to eventually solve issues that we could collaborate. All our services, all our training events are captured. For example, at our quite new NanoCommons user guidance handbook, which should give a good orientation also into these different categories. This is there are already some of the categories, but we are going to fill more of them, where you would find materials already currently available, online available training materials. And this you find everything. The access point is the nanocommons.eu web space. The events, you find also this access via the NanoCommons web space are listed. We have an event library where this event, for example, of today is also listed, and there is waiting for you a tutorial for this event today. So if you go to our homepage and you click this event, there is an easy access and you can download a tutorial helping you to, for example, install the Google Colab notebook. And then further training materials such as the slideshows of today, but also the recording will be accessible, for example, through this link here. We are also listed on the Elixir TESS web space. There is a community there on NanoCommons, and you see here we have already had another hackathon on the Jackpot. This one is determined to give you also easy access where much less material has to be downloaded and pre-installed, so a much easier way to get access to these models. But these details will be explained later by Harry and Philip. The materials are available via Zenodo, open access. Here also the materials already, and there are more materials on the Jackpot suite at Zenodo. Just have a look there. There is a community of NanoCommons, and also the Nano Safety Cluster community is giving you much easier access to that. We are actually aligned with the working groups of the EU Nano Safety Cluster, and the ones who have been in touch with the Nano Safety Cluster so far, or maybe are even members of some of the groups, of the working groups on the mailing lists and cooperating with them, would recognize this headers here. As we are talking a lot about models at the moment, I would like to highlight the working group F is concerned with data management and models. And for example, we have had during the past November an entire day, an education day of the Nano Safety Cluster, and there is material available online on for example, tools, integrated tools for nano safety assessment along this data life cycle. For this, you can also consult the YouTube channel of the Nano Safety Cluster or the YouTube channel of NanoCommons to have quick and easy access to these training sessions, the recordings of them, while the slideshows are, of course, available at Zenodo. So the other one, which I would quickly like to mention, is also in collaboration with the working group F on data. Data fairness is a big issue. We also had an entire session on that. If you're interested in this topic, many things are going on at this moment in this area. Consult these materials there. This serves you quite a good start into the topic. Data fairness is definitely some big paradigm that drives our NanoCommons networking activities. I should say, so having data findable, being accessible, being interoperable and reusable by other people is definitely something that we stand behind with both of our feet. Talking about integration, there is a call open actually until May 15th at the moment. Please, if you're interested, if you are an owner of a tool, of a model, get in touch with us. We would be very happy to be able to offer you maybe a little bit wider use of the things that you have developed by inviting you to be integrated into our infrastructure. So the integration of tools for predictive models, PBPK, for example, modeling applications, computational pipelines, database decisions, whatever, would be very interested to get into an integrative workflow. And with this, you would then also have quite nice access to the knowledge base and could be eventually linked into it. So our experts are definitely available for co-creating and developing with you APIs or graphical user interfaces in order to facilitate easy access. And this should then also enrich the chance of models to be used and also, of course, serve the community in the end. This on the left side is just an example, which is currently more or less readily developed. So you see the 9 nodes that are somehow interesting communication tools between these different models. With this, I would like to already just quickly get you a glimpse on the things that I have mentioned. They are available at the internet. They will be available to you as PDF after this session, so you can consult easily to have access to the different resources that are there already. So enjoy I wish you good success with the training session. Thank you for your interest in our endeavors. And with this, I would like to transfer the presentation to Harry, who would give you an introduction onto the Jackpot.
Thank you very much, Martin. I hope that you can see my full screen. So I'm Harry Sarimbeis. I'm a professor at the National Technical University of Athens, and I'm the director of the Lab of Process Control and Informatics. And I will give a very short presentation about Jackpot, because what we want to do today is to have try to have a hands-on experience. So thank you very much for joining this webinar today. If I try to describe Jackpot in a sentence, then I would say that it is a place to deploy, discuss, share, and use models. And presenting Jackpot in bullet points, it's a web platform where users can develop models on various runtimes and deploy them as web services, validate models and generate predictions, make the models transparent to the users using many different ways of documenting the models, sharing the models to collaborators, users, or groups of users, integrate them with other applications very easily, and meet scalability requirements. So the goal of today's hackathon is to reproduce a NanoQSAR model that has been presented in the literature some years ago. It is an easy model. So we'll develop a model that predicts solubility of C60 fullerene in various solvents. And as Martin said, we're going to take advantage of Google Colab notebooks so that everything will be performed over the cloud, so you don't need to install any software or application in your local machines. So this is how the model will look like. It will have a new user interface where you can create predictions or validate the model by manually entering values or providing a CSV files with the data. You can add description on your model. It is a very flexible. We give many different ways of providing this description. You can add, for example, a QMRF report for your model. You can add PMML representation. This is a really open method of providing information. On the right side, you can see another screen where you can provide information about the descriptors, about the variables that are used in the model, like descriptions, units, or ontological classes. Another functionality that you're going to experiment during the hackathon today is sharing of your resources. So we have this idea of organizing the users into organizations. So if you want to share your models or data sets or other resources with colleagues or groups, then you can create an organization and proceed with sharing. So its user has a private space where he can store his own models, but he has another space, a shared space, where he can share models with other users of Jackpot. Another important aspect to mention is the technologies that have been used for creating Jackpot. We use state-of-the-art technologies so that we can meet scalability requirements. So all Jackpot services are running through containers. They consist of REST microservices. We use Kubernetes for managing the different services. We provide flexibility so that Jackpot can be deployed on a different infrastructure. For example, it can be deployed on the cloud, but also on private servers to avoid, for example, transferring of data through the internet. And we use OpenID Connect, Keycloak, and Red Hat to provide authentication and authorization services. Now, all our models, including the ones that we are going to create today, are supported by APIs. So we have developed a number of API clients in different languages that allow you to easily integrate the models in other applications. This is the example that Martin mentioned before. Here is a risk assessment workflow that we have developed in the context of the NanoCommons project, where you can see that we have different components that have been linked and integrated. You can see, for example, a Jackpot PBK model here that has been integrated via the API clients. We have two different implementations of this workflow, a user interface, but also an integration of 9 nodes. Another example is the Nanopod application. This is an application that has been developed for the sister to NanoCommons NanoSolvit project. Here, we integrate the Jackpot modeling APIs with descriptors APIs. We are able to generate thousands of theoretical descriptors based, for example, on the Delaunay triangulation method. So the final model here needs only a PDB, a crystallographic representation of the nanoparticle, and does all the calculations on the background, creates the descriptors, calls the modeling service in order to finally give us the prediction for different endpoints. So just to summarize, these are some ideas on how Jackpot can serve your needs. You can publish your models as web services. You can provide ready-to-use implementations of your models as supporting materials to your publications. You can collaborate with partners and colleagues. You can share the models with groups, projects, or organizations and disseminate them to the community or the general public. You can integrate models into other applications, and perhaps you can also use Jackpot as your modeling environment. This is a slide with useful links, including comprehensive and detailed tutorials explaining the different functionalities of Jackpot. This is the core development team. Besides me, it is Philip, Pantelis, Pericles, and Jason. All the group members are here today to assist you during the hackathon. So I would like to welcome you to Jackpot and thank you for your participation. I'm giving the floor now to Philip, who will guide you through the hackathon steps. Thank you very much.
Hello, I'm Philip Taganis. I will be showing you the way that we are going to use Jackpot in order to deploy the models. We plan to do this in a fast and easy way. And the whole idea is that I will be walking you through this whole the steps that we need to follow, and you will be seeing the guide on my the right-hand side of my screen, which I'm sharing. Okay, and you can see it, yes. And on the left-hand side is a notebook that we are going to use in order to do our calculations. So you have already received a PDF that shows you some initial instructions that you need to follow. I will go through this just in case someone has not done this. You need to you need to participate in a Jackpot organization called Workshop April 2021, where we'll use this during the hackathon. You should have received an email inviting you to join this organization. If you haven't, it could be some institutional or any other spam filter that mistook this for spam. In order to accept this invitation, you click this, you go to accountsjackpot.org, you click login using the email to which you got the invitation, and then if you don't already have a Jackpot account, you can register for one using basic information that we show you here on the bottom right of the screen. And after you have made and you created a new account, maybe I can, for the beginning, make this a little bigger. You should be able to see your invitation to the Jackpot organization for this workshop on the top right of your screen. And by clicking that, you get this pop-up menu. You accept this, and now you have a Jackpot account. You're a member of the Workshop April 2021 group. So now you can proceed. And in order to navigate through Jackpot, you go to this address, app.jackpot.org.home. I will, from time to time, add some links to the chat, and if the organizers can forward them to you, because it's not possible for me, for the system, to do it directly. However, as we will see, you can visit the Workshop April 2021 organization by clicking through models on the left, and then going through, clicking here on this triangle and going from mine to shared in order to get a view of the models that have been shared with you. I participate in more organizations than the average user here, and together with the development team of Jackpot, of course. However, you need to locate the organizations to which you're participating from the list. We need the Workshop to April 2021 organization, and now we have access to a full implementation of the Jackpot model. This is here, and this we are going to show you how you can reproduce this and do all the steps from a from data to a QSAR model that you can upload on your own. Today you have received another email which shows you this this PDF. Although, in order to be sure, we have made this available, this and other documents also available as a Nodo entry. If Christine or Lee can add this, can forward this address as well, please. Please do so. Okay, you've got it. You can see that if you haven't opened your email or it got lost again, we had to have a plan B. We went through this preparing for the hackathon, and now we're going through these this PDF. There are the two data files that we have here. We have them as backup here. It's not entirely sure you will need them, but we have a second solution. The CSV will only be used for the for testing the model, but we'll more about that later. So right now, in order to briefly know what we're going to face, in order to access Jackpot, you will need a Jackpot account. And first, I will need to ask you if you have joined the organization. If you haven't, please do so. If you had any problems, if you have had any problems, you can be directed to the Zoom breakout rooms where you can have guidance from our team. I will, if Christine or Lee can add them to the chat, please, so people can have a direct someone to ask. So the idea is that you leave them, that you leave the GoToWebinar presentation running, and you open a second Zoom breakout session where experts from our team, either Padelis on room 1 or Pericles and Jason will be in room 2. So in order to access Jackpot, you will need to have a Jackpot account. We just saw what we need, or how we're going to, you could do this. And in order to access Google Colab, you need a Google account. Since we will be using Google services, is something we need to do. Of course, you can only use it only for that, for this purpose. Okay, so Jackpot 5 is, as we saw, is a powerful platform that can allow you to do toxicological in silico predictions. And on top of that, after that, you can use Jackpot to deploy machine learning models incredibly easy and make them available to the community. What we'll see is how we can reproduce and publish in Jackpot 5 linear nano QSAR model. This comes directly from a publication, and sorry, I'm trying to advance the page, but it's, yeah, okay, I did it. No, that's the paper. It's about the prediction of solubility of C60 fullerene in various solvents by Garagesi and Alamdari. For the purposes of this workshop, we're going to show how everything can be done by using a username and a password. If you just want to take a look at the Jackpot, as we will see here, I will log out. No, here, sorry. If someone wants to log in, it is possible to take a look at the tools and use them by using the GitHub and Google accounts. And but right now we're going to just use the username and password option because it's simpler for the latest steps that we want to follow, and we want to have a more uniform approach. When someone logs in here, and I urge you to do the same steps with me, as you see them progressing on the screen. I will try to do that at a relatively at a pace that you can follow. Right now, what we see here in the initial home page is a list of all the resources that have been shared with me. It is a lot of models and sorry, let's go here. But also there are some data sets that I have here. But if I wanted to take a look at the models, these are mine. As we saw, I can go to shared, and you should all be able to see this workshop April 2021 organization that you can use. The organizations are closed circles of people you collaborate with and choose to share your work with, and you trust them enough to give them access to your work. So this, as we will see, can be done on various levels. You can just give people access to execute something, to execute the model without being able to modify it, or you can you're also working with them, and you want them to be able to change the model page with you. So currently, what most people will see is this page that we see here. The space here is blank because you don't have you haven't created any models yet. But the populated homepage looks like this, and what you saw on the left with me. So yep. What we do now is that we, instead of going to the publication and having to go through the data ourselves and actually transfer that to a file, we can retrieve that from in ready-to-model format from the NanoCommons database. Its scope is to make available some models that are in ready-to-model form, which means you can just download them and use them. Okay, so I've copied and pasted this. What you see now is on the left, there you see the dataset retrieved, a small description from the S2 Nano database, and you can select multiple datasets here. What happens actually is you need to do this if your screen is relatively small. You get this, you don't see the small arrow icon, but if you expand it a little or make the change the magnification, change the zoom in, zoom out, you will be able to see this. So, or you could do this by selecting that. You go to the solubility of C60 fullerene in various solvents. That's what we need to do. And after we have selected it, then you just download the dataset. Right now, I will open it. While it opens, this also allows us some time to be able to synchronize work with everyone else. So this is what it looks like.
Philip, we have a couple of questions.
Oh yes, I can't actually see them. It's possible. It's only possible for you to see them. Okay.
Is that correct? You don't have a questions tab on your?
No, they just appear to you.
Okay, sorry. Okay. Is the data set called metal_oxide_cytoxicity?
No, I think they have downloaded another one. This was called 70 model reduced.
Okay.
But you need to zoom out a little and make sure you select this one. Maybe I think what someone did is they just clicked download dataset and they got the from the first entry. We need the last one, solubility of C60 fullerene in various solvents. Okay, I think we solved that one. Another question?
It was related. Is there a link here with data? Could you send the link in the chat to the data set, or is that?
There's a link to the database. They should have the actual PDF file here. And if they don't, they can find it on the Zenodo, which we posted earlier. So there shouldn't be any problem with that.
Okay.
Hello, Lee?
So there is a question: yep. How to get the Jackpot shared database inside Jackpot? I'm not sure I understand that question myself. But...
yeah, you need to. If someone is here. I will try to understand this. So if you go to models, then initially you are looking at your page. You're at models mine. You need to go here at the triangle, click it, and go to shared. If you go to shared, then you will see the organizations in which you're participating, and you select the workshop April 2021 entry. There you should be able to see these ones. There's one, the general one that we have, one by Harry Sarinvis from our team, and Lion must be a participant, another participant actually, who perhaps completed the whole tutorial. Yeah, that's encouraging. So Lee, do we have another question?
No, I can't see any more now.
Okay. So by this point, you have we have all joined Jackpot. We have an account. We participate in the Jackpot workshop April 2021 organization. We have the data sets that we're going to use. So let's see how we're going to use it. We are going to make use of the Google Colab platform. It is a nice way to run code in the Python programming language without any need to perform any installation whatsoever. Because we actually tried to have workshops where people were encouraged to install Anaconda and other forms of Python notebook environments, that took a lot and it was painful. So what a nice way to be able to have both things is to have both ease of use and possibilities is to use the Google Colab notebook. You should see the link here, so anyone who wants the links, I think they should be directed to the Zenodo link, and they can download the links from there if they, from some reason, they haven't received the PDF file. So what you would get is this. You would see the Colab notebook. If you open it and it looks a little a big screen of gibberish here, as you see on the bottom right screen, you just need to click the Open with Google Collaboratory icon. I will try to zoom in a little. Yeah, just a little more. And there we are. We need this button, which will be on the top of your screen. And this runs the Google Collaboratory application. So when we are here right now, because I'm part of the team, I can also modify it, but you can't because that's the permissions that we have set. So what you should do is that you need to save a copy in Drive, which will allow you to make modifications and actually run this notebook. Please be careful with, of course, this is something that has only limited capabilities to do to read data, and no access whatsoever to the data in your Drive. But in general, other notebooks could have more capabilities. Just be careful with what you run. This, of course, is something really that doesn't do much in terms of accessing any data in your Drive. If now I have a copy of the workshop notebook that we saw before. Because I was logged in as a Google user, I didn't have to do anything. However, if someone was not logged in before, then the Google sign-in required icon or pop-up message should appear, and then you would need to do this sign-in. And of course, after doing that, you're ready to run the Colab notebook, and we will see what we're going to do. So what we're looking at the notebook is actually a way to run code. What you can do right now in order to be sure what you have done and what was not pre-existing is you need to go to the edit menu and click clear all outputs. This will, as you see, the moment I do this, erases any output that was existing beforehand. Here in the notebooks, what we get, we can have the titles, we can have some boxes where we put just text, or some black boxes where we have the code. This code we can actually run. In order to see what this does as a first demo, we click on the play icon on the triangle, and then we will see what happens. First one took a little longer because, as we see here, it needed to connect to a runtime, and this is using the RAM and the disk locally. An interesting thing that we need to note here is that within the Google Colab notebooks, you can also get access to GPU processing power free of charge. Of course, with some limitations, because this is usually charged a lot. Google, in order to show you the possibilities of this technology, allows you to use GPU algorithms within its notebooks. So while we were talking, the first command ran, and we see the outputs here directly below. So we collected, we pip installed something, the Jackpot Pi package here, and what we see here is a nice message: successfully installed these packages, the list here. In the first part that we had just an introductory text, we saw pretty much what we have already shown in the PDF. So all data, all input data are here, and you could do this. Okay, so the second, you should be able to run. Please ask any questions to Lee if you haven't been able to follow up to until now. But as you see, because we choose a piece of code and run it, it goes relatively smoothly, and we see directly what results our actions have. So we install a specific version of scikit-learn. We install pandas. This is done. Some packages are included in Google Colab, but we added some options here in order for you to be able to run them in other environments as well. If you don't want to use Google Colab, of course, you can run Python notebooks in a plethora, in multiple environments. That's not going to be an issue there, and they can be not on the cloud. They can be on your computer with restricting access. So that's not, if you have any privacy issues, of course, they can be handled, they can be addressed by that. So we have already done this, getting the data from the NanoPharos database, and we selected the C60 solubility of C60 fullerene dataset. We have it here somewhere on our computer, and now we're going to import the Jackpot Pi library. That's what we import pandas, and we use the acronym PD Now we import from Jackpot Pi, import Jackpot, and we're going to refer to it. And there are several tools, several libraries that we want to make use of, and gradually we will import them. The linear regression, the min-max scaler for pre-processing the data set, the pipeline, which will allow us to have to impose specific actions on every data set that is fed to the service, split the data into training and test, and the cross-validation scores will show the covariance and the randomized search covariance. Okay, we'll take a look at that. And right now, what is important for us is that we need to upload the file, and this is the command that does it all. Sort of going through the code in order to show you what is happening. You understand that there are some parts of the code that you will not need to change if you are dealing with different data sets. So we run this code, and small two options will appear. I could cancel the upload, and of course I would get an error, but if I choose the file here, I choose the 70 model reduced Excel file that we saw before, and it gets uploaded, and afterwards the rest of the commands are executed. The user, I asked it to print this. The user uploaded this file with this length, 17 kilobytes, and I print the headers of all columns by here, the list of the data frame. So in order to view and pre-process the data set, we are here. Maybe I will just go through the first couple of commands and take a look at where everyone else is. So we'll see that we are on the same page. Right now we have done this, and we are on step 3, viewing and pre-processing the data set. Of course, as you see, the instructions follow the structure of the notebook itself. So if we place the magic triangle here, we take a look at the data frame where we see the various variables, and we see the for all solvents that are available here, we see several descriptors that have been calculated as explained in the paper, and here we see the logarithm of the solubility. So we can generate descriptive statistics on the data set using the df.describe. Before we just gave the name of the variable where we have of the data frame where we had stored everything. But if we do df.describe, we can get descriptions that show us how many data points we have for each variable, the mean, the standard deviation, the minimum, and the percentiles that are here from the lower percentile, the 70, the upper percentile, and the maximum. So maybe I'll stop here and briefly to ask if there are any questions and give you time to get for all of us to get into the same page.
Philip, there was there was a question with regard to starting the code. I started code with Jupyter Notebook. Is it okay to do so?
It should be, yes. This will install everything there. What we would need to do is, if there are any problems, because I'm not sure anyone else has done this, has followed the same path. Probably everyone else is following the Google Colab option. It should work. I mean, mostly we do a development work in offline notebooks, But this is also a nice way for us to be collaboratively working on something. That's the use case scenario where we use the Colab notebooks. If more guidance is needed, the Zoom sessions, breakout sessions are ideal for this, to whoever participant would like that.
Okay, thank you. There weren't any more
just...
questions. Yeah.
Okay. Okay. So right now here we need to define the independent variables and the endpoint to be predicted. So the independent variables are those, the ones that we're going to use as input, and the endpoint to be predicted is what we actually want to build the model for in order to provide us predictions for this variable. So we will split the data randomly into training and test sets, where we have 75% of the data used for training, 25% used for testing the data set. So if we do this here, yeah, actually there's nothing to print, that's why we don't see an output. And then we can develop in this next stage a pipeline which consists of scaling the data first and applying the the MLR, the multiple linear regression algorithm, where our algorithm of choice, which is our algorithm of choice for this model. We call this pipeline linear. It calls the pipeline function and uses this as inputs, where we have the min-max scaler. They will be scaled from the minimum, between the minimum and maximum values, and we would only get values from 0 to 1. This is very useful when we are making a model, because we need to be sure that they are in the same scale. And we will be using the linear regression algorithm. So we've already done that. Again, here we don't see any output because we just didn't ask for anything to be printed. And now we will train the model. Here we are. And using this dot fit according to this pipeline. So we use this pipeline with min-max scaling and linear regression being imposed to the X-train and Y-train data sets. Here we have just in X-train, we have the input data set, the input variables, and the X-train will provide what the variable we want to predict. So in order to see how the model has performed, we print the training score, how it scores in the trainings part of the data set, in the testing part of the data set, and how the total score is. So that's where it got. It's at 0.9. So it's a nice model, nice enough for us to be to want to post it on a platform and share it with others. So at this point, we are on 5. We need to get authentication to access Jackpot. As we see, we're going to use this using our username and password combination. There are ways to do that for others who want to use their Google account or their GitHub account, but we I will be presenting this simpler option. This would be more useful for developers because they use tokens, and it allows us to do integration. At this point, I would like to briefly direct you to the to this page that we have here. It's the page where we have the documentation. So Lee and Christine, please forward people to this, forward this address to people, the quite vice versa. So what we're seeing now is also described here. It's the central page for Jackpot, and you, a developer would have all the information needed, because What Jackpot stands for is easy integration to multiple platforms, and what you can see here, this can be done with .NET, Java, Python, JavaScript, and Golang. And what we're seeing here is a small part which just talks about deploying the models and using them. Of course, we see here about scikit-learn, but there's also XGBoost and R models that integration that are available. That is available. So, in order to get the authentication to use Jackpot, first one will need to point to which Jackpot instance he she wishes to refer to, because there could be multiple installations or there could be a private installation for your organization. So the user is prompted to enter a username and password here, which I will do after pressing the triangle here. And while the code is running, I will give you my you give in your username and press enter in order for the other box to open. I've made a mistake on my token, sorry.
Philip, while you're doing that, it's Christine here. I've got a question. Are the scores displayed, the correlations? Is it possible to evaluate the model performance by estimates of error?
I'm trying to understand exactly what the question is about. So right now we chose to show just the training score in terms of R². Any other metric is available. If you have the X and Y, the result of the prediction, then you can calculate any metric desired. We just provided here the R², then there's the cross validation here from a five-fold cross validation. I think that covers the question, and if there's anything else someone would like to have, please let us know. But of course, what you see here is not Jackpot itself, is Python commands. So we use them in order to make develop the model in Python, and this is where the actual use of Jackpot starts. Wasn't there another question, Christine?
No, that was the only question at the moment.
Okay, thank you. So after pressing here in the Jackpot request key save command, I successfully remembered my username and password and added that here. So the other way, which is you see, it's the only command that is on the only box where we have everything in green. That would be the other way to do it within an API key. Don't do this because it will not run. If I do this now, it just thinks everything here is text, and that is done on purpose because the API key and the token included here is only of limited time, is valid only for a limited time frame, and it would just make you think that something is not working correctly, when in fact there's no actual problem. If you have done this and you have received a nice green message here that the API key is set, then you are okay. You have been authenticated, and that's how you know that everything works all right. So deploying the model, this is the juice here. This is the one command that we need to take a look at. I will try to expand because we'll see in a better way what we are providing. This is the pipeline linear, the pipeline we're referring to. We're giving the input data set, the output variable, the data set with the data frame with the output variable that we want to predict, a title. So please, what you see here in all caps.
Your microphone, because
I somehow insist to make Microsoft headset work with Mac, so that's I guess that's what you deserve. So we were here at this point, and it actually got me to the most important part of the movie. Here we have this model ID. We get the ID of the model. It's a serial number. If you take a look at it that way, we'll use the Jackpot deploy sklearn command. We provide the pipeline. We provide the input and the output data set. A title. Here it's the solubility of C60 fullerene in various solvents dash username. So please change that. You don't need that to be the same with everyone else, because others could run this command and upload something that's called username. So add anything else that makes it distinctive. And there's a description. You can add a description here, but for brevity, we shouldn't change that. We want to have the meta information for the model. We'll see what this is, and we want domain of applicability calculations for the model with the xtrain variable. So if we run this, what we get in response is we have the model ID, and it was created in 1.3 seconds. Usually it's about half a second, something like that. So this is the actual work that we needed to do in order to get the model, and not to spend any more time with this. We can use our model here over the user interface at this URI. If we click on this, actually, this page was created for my model automatically. Remember, I just added the Philip D here, and I have it here. It takes little time in order to be able to do this, and we always also have the various tabs that are available for each model. And right now we passed through the sixth stage. We deployed the model, and now your QSAR model is a web service. You can access it through the Jackpot interface. I had previously logged in. That's why it took me to this page to which I have access. So one thing that I would like to do is now leave a couple of minutes for everyone to ask their questions, make sure we're all on the same page, and we'll see some additional capabilities. My initial idea was to go through the whole the part of the tutorial until here in less than 30 minutes. I think we managed to do that. Are there any questions, Christine or Lee? Okay, so I hope that everyone has done this. What we are here actually, once the first part has been completed, we can start exploring the additional steps for everyone. Please, again, don't hesitate to contact us for any questions that you may have, especially the people in the breakout session. They could be waiting for you. They are waiting for you, but they could be lonely. So we have we'll see how to get predictions from our web service, and we'll do it both ways actually. Once we have the model, and this model ID was generated to us here, as you see, It's the model with the UID. This is included in the last part of the URI that we see here. And if we click on this, we get predictions from the model, which is something we have created, of course, but it could also have been something someone else has created or that we have shared online. And it is possible now to generate predictions with one command. If you have the model ID and Jackpot knows you have access to it, then it will allow you to get predictions. So if we call the predictions variable, this is what it looks like. So another way to use the same model would be to do this over the user interface, which is initially here in the overview, we haven't provided anything. There are the features here, what we want to predict, and the independent features. Now, right now, we have the predict validate tab where we can predict, and either we can input some variables here by typing them. Of course, I'm typing values that have no meaning. That's not what we want to do right now. But for a quick check, that gives you an idea. If you wanted to use another data set, you could do that. To provide more values, you could download the template data set here, and what you would get, my program is opening that right now, or you would get a template which you could later upload here using this button. As you see, there are explanations popping up. So right now we need the CSV file, not the Excel file that we saw before. It's quite easy to go from the CSV file if you are into, if you have the Excel, you can save it here, save it as a CSV file. But we won't show how to do that here because we have done this work and provided you with the CSV file in the Zenodo post that we have entry that we have made available. So as I already have it, so okay, sorry. Let me pause a little. This is what the dataset looks like. You have the headers here, and you could just add your the values for the for your variables, your input variables, and run it, okay, and save it as a CSV. Depending on your program, that's on a different menu. That's we won't get into that into more detail. But right now we have the CSV file. We choose no data set that doesn't have an ID. So if the ID is non-continue, that's what we will do here. And we take a brief look at the data set, and then we choose to add the domain of applicability on predictions, or don't add. Of course, we want to see more capabilities. We click this button here, and we start the procedure. We get some notification of what is going on, and the task is now running, the prediction task is running, the dataset retrieved, model retrieved, etc., etc. So we go to task completed successfully. This is what we want to take a look at. We get the estimate for the what the DOE value should be from the leverage method in our dataset. And what we see here is all the values in the dataset, or the predicted values. So we have the values for the solubility and the domain of applicability calculations. What is important here is that, okay, it's not just about me or you trusting your model. You need to have a place to discuss your model. You would need a way to get feedback on your model. So it would be nice if someone could provide you feedback and say, okay, this model scored 0.92 on the fullerene dataset by X et al. So I save this and someone else can reply. People here, it's sort of a social network for models where we can discuss the efficacy of models and their suitability. What is nice here in that we can also get the meta information for the model, so we have better reproducibility. What scikit-learn version was used, the detail of the algorithm, which of course here was pipeline, that doesn't tell us much. However, we can get more information here by seeing that we have the MLR, the multiple linear regression algorithm, and also the scaling that was done. Okay. Another thing that you could do, you could try out here at this stage, is that you go on the bottom right of your screen and choose the edit button. Of course, if you click save, then everything is saved. That will do that at the end. If you choose share, then you can choose to which organization you want to share this. So you go to workshop April 2021 and don't give everyone write access, of course. You can choose to give execute access to others. So if we click on the blue button here and click share, we get a successfully shared notification. So if I click it again, okay, nothing happens. But if I click outside and save it, then I can go to the models page, go to shared, go to the workshop April 2021 organization and see what has been shared there. And I immediately see my the model that I just shared. Of course, I can change it because it's my own, but okay, here I see another one called username. Of course, it's oh, that's mine. Yeah, that's mine as well. Sorry. There's another one here called by Pericles. There's another one by Lion. So you could do this all too. This is how you can share your model. And this is how you can get, how you can add the meta information to your model. This is the last part we will be exploring. I should ask if people are have any questions at this point.
Okay, Philip, there's a request,
Yep.
or I don't know whether it is a question or a request actually. Could you please repeat the steps after running number 38 predictions in Google Colabs?
After running, the step to get predictions.
Mm-hmm.
So after that or this one? I'm not sure I got the question correctly. Could you repeat that, please, Lee?
So could you please repeat the steps after running colon 38 in square brackets predictions in the Google Labs? I'll put it in chat, that one, because it's a bit hard to. Sorry.
I have a different numbering because it depends on how at what succession you have done this after running predictions in Google Colabs.
I guess, Philip, the question is about the Jackpot interface. I mean, after the model has been generated into Jackpot.
Okay. So after the model has been generated on Jackpot, you go here to models, you go to mine initially, because you just want to take a look at your own data set. So my model had this title. So I view this here by clicking on the eye, and here I am on the web page of the model. And of course, this overview, we'll take a look at this shortly. And there are several features here, the independent features and the predicted feature we want to predict. There's a predict validate option. There's a discussion where we see what we can enter. And we also saw about the meta information. What would be interesting for people visiting your model page would be this, where they can either predict or validate and upload the data set with the required features or values. What actually will show something new here. We upload the same data set. It doesn't matter. It could be another one. The data set formed here is this. Either we go validation for regression or validation for classification. We're regression, and we click the Start Procedure button. And we get the report here about the model validation. So you get the QQ plot and the real versus predicted graph. Lee, did we cover our
Philip,
participant? Yeah.
Can you repeat the steps that need to be followed in order to share the model with the workshop April 2021 organization?
So we go to share. On the bottom right, you get this pencil icon, and if you click it, you go to the left where you can see on the bubble you see share. So if you click share, you don't give write. Clicking here would give someone write access. You don't want to do that, at least for now. So if you go to execute, you choose the sorry, I had it, and then okay. If I wanted to give access to someone else, then I click share, this blue button here, and immediately I see the pop-up message here, successfully shared. So I know I've done it correctly. So I click anywhere outside the window, the pop-up window, and I save my model. In order to be able to take a look at it in the shared organization and make sure that it has been successfully shared, I go at models. Right now it takes me to models mine. That's just mine. So I go to models shared and click workshop April 2021 and see what has been shared there. And okay, I see nice people have begun to share their models and made them available. So Harry, do you think there's any part of the question that we left, or should we?
Perhaps we should pause for a couple of minutes so that we let everybody share their models and check that everything is correct, or let us know about any issues or problems that they're facing.
We've got it's just Christine here. So yeah, I think we answered. I think Philip, you answered that last question. But someone when I do the prediction or validation, I get an error number 401. Do we know what?
Error 401. Maybe they are out. They have logged out. maybe check if you have logged out. If you go to the bottom right, to the top right of your screen, maybe you're outside and your token, your username and password have expired. It could be that you're here, that you're at this point. Either way, you can try to log out and log in back again. If I log out, I get directed to the initial page, and I get to log in again. It takes me to my page. Okay, so in order to give users of your model a better idea of the work that has been done, you can use this menu here by this model, and I will change mine, and I can add some data here in the overview, which can be, I'm free to add anything I want. It can be a QMRF report or the PMML representation or any annotation. So we have made available in the workshop April 2021 organization a model that has been where we have added all the additional information. We could have links here. We could have the QMRF report and provide statistics. So in order for better to comply with the OECD requirements, you could have this. What we also provide here is the model in PMML format, and that's a last part of the mod of the presentation, where you can that we will show. First, you see here that we have provided a QMRF markdown template that users can be directed to, and this actually has the necessary fields that you need to enter for your model as a description. And there are multiple markdown editors that you can use, and many of them that you don't need to install at all, and you can just add the information. Please also be aware that if you take a look at the features, you can edit them and provide the ontological classes as well in order to have a fuller representation of your model. And for the last part, we will be showing how we can create the PMML representation of the model. So we run this last bit of code here, and we will be using the sklearn to PMML package. And we provide a name for this. At this point, we don't see anything happening, but if we go to the files icon on the top left of the screen, something else appears. It is a file browser where the model that we previously added appears, but also the PMML representation, which we can edit here. And the PMML representation allows you to share what your model is, how it is structured, and what the coefficients for every variable are. So it could be reproduced across platforms that speak PMML, so to say. And this is, of course, available for certain algorithms. Please bear that in mind as well. So you could have the QMRF report, you could have the ontological classes, you could have the the PMML representation, that would give people a very good idea of your model, of its capabilities, and what it can do for them. And if it does or if it doesn't, they can provide you with their feedback on the discussion tab. You can test it as we saw here. And a last word, more information on the Jackpot platform can be found if you follow those links, because Jackpot has the capability for you to upload models, but it also is a suite of tools that allows you to do QSAR modeling, PBPK models, image analysis, and read across methods. A comprehensive technical documentation is given at this address, as we saw before, and we will be adding this and other use cases and examples here. Okay, that is all I had to say until now. Do we have any question to respond to?
There are no questions at the moment, no?
Mm-hmm. Okay, just one final look at the shared space. Okay, more are coming up. The idea here is to get as little requirements to be able for you to be able to make your model available, and other people being able to use it with minimal programming skills. I mean, if you take a look at those tasks and what each command means, you can get what they do, and you don't need to install anything. I think you saw that today. The actual commands that do this are pretty straightforward. You specify what you did, your input and output variables. You specify some parameters for your model. You make it available here. You get the URI. You click on it, and you have your you go from a local model that you can use to a web service that you can use either here to get predictions within Python, or within a web page or user interface on a web page that people can use and comment, and has the capability to host meta information, ontological data, be used for discussion, and provides information about how it was created, also complying to OECD requirements. Harry, do you have any final comments before we close, because we're 5 minutes past our time?
No, I think that was all. If some of the participants want to work further on this exercise, please contact us even after the end of the hackathon. We want to make sure that everybody is able to produce this model and share it with the organization. So that's all from my side, and thank you again for the participation.
I would like to thank, on behalf of the NanoCommons project, the NanoSolvit project, the Nano Safety Cluster, Harry, you and your team, Philip, for driving us through the Colab assisted Jackpot suite. Also, many thanks to Pericles, Pantelis, and Jason for support in the Zoom breakout rooms. Thanks to everybody from the audience for your participation, for your willingness to go into that. Always a challenge to do it over the net. Thanks a lot to Christine and to Lee for support on the GoToWebinar. I had the impression that we could solve as many of the problems as we had in our Zoom breakout rooms in addition to the chat box, which is tricky, of course, always to express yourself, to be understood, and to get your answers almost in real time to be able to follow. Do not forget, there is the offer of NanoCommons that we have TA services, so transnational access to the tools. This could definitely be used for integrating models that you run, that you have developed eventually. There is a target call still open until May 15. Get in touch with us. The internet address or the email address I have given in advance. Everything will be posted onto Zenodo, and you find it either via the NanoCommons events page or via the Zenodo or at the YouTube channel of our project. The email address actually is info.nanocommons.eu, and we put you in touch with the experts to further develop the idea of such an application eventually. Okay, thanks a lot. Have a nice afternoon, evening. Goodbye. Thanks to the experts in Greece.